Physics part 240. We've got an example for you. Calculate the equivalent resistance of the arrangement of resistors in the figure. The arrangement is equivalent to 6 omega resistors in parallel. So the combined resistance R is given by 1 over R is equal to 1 over 6 plus 1 over 6 is equal to 2 over 6. Don't forget to find the reciprocal of this value. Thus R is equal to 3 omega. Now it's your turn. Number 1, calculate the equivalent resistance of the arrangement of the resistors in the figure. Hint, first find the resistance of the parallel combination. Number 2, calculate the effective resistance between the point A and point B in the network figure. Potential dividers and potentiometers. 2 resistors connected in a series with a cell each have a potential difference. This may be used to divide the EMF of the cell. This is illustrated in the figure. The current in each resistor is the same because they are in series. Thus, V1 is equal to IR1 and V2 is equal to IR2. Dividing the first equation by the second gives V1 divided by V2 and R1 divided by R2. The ratio of the voltages across the 2 resistors is the same as the ratio of their resistances. If the potential difference across the combination were 12 volt and R1 were equal to the R2, then each resistance would have 6 volt across it. If R1 was the twice magnitude of the R2, then V1 would be 8V and V2 would be 4V. A potentiometer is a continuously variable potential divider. In section 7.2, a variable voltage supply was used to vary the voltage across the different circuit components. A variable resistor or a rheostat may be used to produce the continuously variable voltage. Such a variable resistance is shown in the figure. The fixed ends AB are connected across the battery so that there is a full battery voltage across the whole resistor. As with the potential divider, the ratio of the voltage across AC and CB will be the same as the ratio of the resistance of AC and CB. When the sliding contact of C is at the end of the B and the output voltage V out will be 12 volt. When the sliding contact is at end A, then the output volt will be 0. So as the sliding contact is moved from A to B, output voltage varies continuously from 0 up to the battery voltage. In terms of the terminal PD, V of the cell, output V out, the potential divider is given by V out is equal to VR1 over R1 plus R2. A variable resistor connected in this way is called potentiometer. A type of potentiometer is shown in the figure. Note that there are 3 connections. If a device with a variable resistance is connected in series with a fixed resistor and the combination is connected to a cell or a battery to make a potential divider, then we have a situation of a potential divider that is variable between certain limits. The device of variable resistance could be for changes in the illumination or the temperature cause a change in the resistance. And one of the components of the potential divider so that the potential difference across this component changes. The change in the potential difference can be used to operate control circuitry if, for example, the illumination becomes too low or too high, or the temperature falls outside the certain limits. A potentiometer can also be used as a means of comparing potential differences. The circuit of the figure illustrates this principle. In circuit, the variable potentiometer resistor consists of a length of uniform resistance wire stretched along a meter rule. Contact can be made to any point on this wire using a sliding contact. Suppose that the cell A has a known EMF of E. This cell is switched into the circuit using the two-way switch. The sliding contact is then moved along the wire until the center zero galvanometer reads 0. The length IA of the wire from the common zero end to the sliding contact is noted. Cell B has an unknown EMF EB. This cell is then switched into the circuit and balancing process repeated. Suppose that the position at which the galvanometer reads 0 is then distance IB from the common zero to the sliding contact. The ratio of the EMF is the ratio of the balance length, and that is EB divided by EA is equal to IB divided by IA. And then EB can't be determined in terms of the known EMF EA. We'll have an example for you, and that's what we'll do in the next video. That's all for the day. Bye bye, take care. See you next time. Talk to you later. Take care.